Good evening, everyone. Welcome to Turnip's webinar on AI for software engineering. Thank you for the exceptional response to this webinar. We received 5,000 signups, which is quite incredible. I'm Rahul Kapoor, founder of Turnip Innovations. This topic today is very close to me as I'm actively exploring the field of AI. There is a lot of innovation happening in AI, but nowhere is it as dramatic as the fields of software engineering and information technology. So today we have an eminent guest who is working at the forefront of AI and software engineering, Mr. Suvodeep Pyne. He did his B.Tech from IIT Kharagpur and Masters in Computer Science from Texas A&M University. He's an engineering leader who has 2 decades of experience, and he holds multiple patents in the fields of scalable software systems and real-time analytics. Shubhadeep has worked with global companies like NVIDIA and LinkedIn as a software engineer, and currently he leads the software team at Startree AI as a founding engineer. So with this, I would like to welcome Shubhadeep and bring him on stage. For the audience, I can say that thank you so much for coming in such large numbers. Please make use of the time of Shubhadeep. You have only 1 hour. So make sure you ask pertinent questions in the chat. Do not put your name and college name in the chat so that it is easier to identify relevant questions. Otherwise, just enjoy the session. And Shubhadeep, I'll hand you the session. I'm around if you need me for anything.
Thank you so much, Rahul. Pleasure to be here, and I welcome you all. I hope this session will help you as much as it helped me learning a lot of things as well. So I'm planning to cover a few things and around how AI is transforming software, and hope you also find it useful. It's kind of I would say a very exciting time, and I wish you all the best, and hope you guys have a fun talk. Also, yeah, feel free to interrupt me and post questions on the chat so I can probably just knock them off as we go while we stay in context. And yeah, let's continue the session. So I think Dr. Kapoor already mentioned a little bit about me, so I won't bother you with most of the details. I have been part of the tech industry for a bit now. I have been part of building large-scale systems at LinkedIn, worked on the GPU team at NVIDIA for a bit, and also had my own stunt around founding companies, being part of 2 companies pretty much from the very early ages, and to a decent scale right now. Other than that, I enjoy spending a lot of time with my dog. We go on hikes, and I also have a little fun playing with AI as well. So this is me and my dog Simba, sitting on the stand, walking on the moon. Now with latest tools, it's a lot of fun playing around with images. So I just wanted to throw in that as well. Cool. Let's get started. So yeah, what's the agenda? So I'm trying to focus on how to do more with AI, right? What is the current landscape? What are the things going on? Starting with a little bit of a primer on what the basics are so that everybody is up to speed on things. What are the core concepts, and what are the things that I will be building upon. I'll talk a little bit about how product engineering is changing because of AI, how security is changing because of AI. Observability and root cause analysis are very close to my heart. I've been part of that industry for more than 5 years now, and I've really delved into the nitty-gritties of things, and I'll probably share a few tidbits there as well. And yes, we'll probably look at what an AI agent experience today looks like. Shall we get started? Cool. All right. So where are we? So we have like an avalanche of AI tools and technologies today, and pretty much every software like direction or every tool under the sun is now AI-fied. So we have coding, we have image generation, media generation, even medical science like AlphaFold, like pretty much all video generation. Everything is being touched by AI, and it's kind of transforming the way we are creating things with the generative pre-trained transformer, the GPT models. And the other side of the story is that the market has been exploding, right? So ChatGPT users have been like the fastest growing application ever, right? And we only just see the beginning as more and more applications keep growing at like a scale that we have never seen before. So just wanted to throw in there and the excitement and why this needs our attention. It is a movement probably larger than industrial evolution, and we should be very privileged to be part of it. Jensen is the CEO of NVIDIA. He mentioned that the chip performance is 500x in the last 5 years, and he expects the trend to go forward with GPU. So we saw Moore's law sort of, flattening out a little bit on the CPU side, but nowhere close on the GPU side so far. So the performance has been increasing, and that also is what is powering a lot of the training today. And that this scale has been fundamental to the performance of GPT as well. So as you see the size of these models go up, we are almost seeing a linear sort of growth in the performance of the model versus the size of the model. And that also, NVIDIA is at the forefront of it. And that basically puts them in a great position and also helps them empower this revolution. All right, so what about agents? So I'll talk about what agents are in a bit, but just be with me here. The thing that agents are actually also growing at a phenomenal pace here, when the length of the AI tasks that they are able to do independently is doubling every 7 months or so. But this statistic is also not that old, so this trend is also actively changing. It could be faster, etc. But we are seeing with very recent models like GPT-5, which can go probably over an hour without human supervision. And this is actually a scale that, even with this level of performance, we are able to perform quite complex software tasks, which require multiple steps to happen all within one session, fully unsupervised, which is pretty amazing. And that has been also one of the key things why we are able to do a lot more with agents. Cool. I'll touch upon this as well. It's just throwing in there. Energy consumption has skyrocketed because of AI, given the amount of electricity these GPUs are burning. So the trend at which we probably might hit the world energy levels in let's say 15 years. So that's how much energy is just AI training is taking, which I find is mind-boggling. But I mean, even though these GPUs are getting efficient, that is the amount of energy we are spending in training these models. All right. So this has been for all you engineers out there who have been in the industry as well, Stack Overflow has been our darling for a very long time. I don't know whether some of you folks have been around that day also, but Stack Overflow was my go-to place when we used to go and find questions to things that we did not know or ask questions. But post AI, things have changed. Post AI, people are asking questions to the AI now, and Stack Overflow is now doing surveys. And they're basically saying that more than 50% of folks are using AI, 80% are using some form of it on a daily basis, and the number of questions has actually started to go down, and we are back to early 2000s level in Stack Overflow in terms of monthly questions. Shows the changing industry. A business which is very successful may not stay that successful unless you keep on innovating. And also the overall trend in the way people behave has changed, right? So now folks can just directly ask questions to ChatGPT and get answers versus waiting for somebody to come and answer on Stack Overflow. All right. So to sum it up, in current state of AI, what are we talking about? So we are seeing a good amount of penetration for product software engineering disciplines, and these are growing. And that is one key takeaway from here. Model performance is increasing over long-range tasks, right? And that is powering, the sort of iterative workflow, right? Multimodal becoming mainstream. Multimodal here basically means things which are not just text. This could be images, this could be audio, this could be anything which, basically has a stream of tokens that we can pipe into a model. And yes, rise of AI workflows. So these are different kinds of tools that I'll probably share in a bit, which basically lets you do a multi-step process through, through a graph and get complex tasks done. And lastly, agents. Agents basically, in this case, are an extension of workflows where the decision-making authority is also with the model itself. And I'll again share this a lot more in the next section. Cool. Let's talk about agents. So I'll probably run through this a little bit quickly, but yeah, what are LLMs? They're function approximators. Given a list of tokens, what's the next one, right? And we just spoke about multimodal. There are some good resources around YouTube, particularly the one by Andre Karpathy. He was the AI director at Tesla, and he has a great session on neural networks if folks are interested to explore more. But roughly today, the state we are in, the context is around 100K, which is like 75,000 words or maybe around 2,000 pages of text. So it's pretty large, but there are certain nuances that I'll also talk about. Going forward, we're probably going to build on top of this. So we know that models are function approximators, and what we're trying to do is build on top of them. So today, if you upload, let's say, this is, I work on Apache Pinot. It's our real-time analytics database that we ship. This is an open source tool. So if you basically throw in a log in there, log file, which is like probably a megabyte of log, it's around 350,000 tokens, but you can throw that into Gemini because Gemini has a 1 million context window, and it will tell you what is the problem. Like in this case, there was a segmentation fault or some signal that kind of fired. Oh, it is a SIG-SV. But the model is able to parse through tons and tons of text and kind of give you a good summary. And this is one instance where we are able to leverage a large context window. Now, if you look at the intelligence part of models, right, they have also grown over time. Like, for example, in case of the more thinking models, GPT-5, Claude 4, Opus, etc., things are a bit on the right, and they're already challenging human levels of intelligence. Of course, there are these other set of models which have been older, or probably they are not at that level, but they are still quite quick, and everybody has their own use case. Models which do not think are faster, so you can use them for simpler tasks, and models which do think, you can use them for reasoning. So there's a space for that here, but this kind of gives you a good landscape of where we are. All right. So how do you empower models with tools? And this is like a very crucial flow in how we are building on things. Now, when LLMs can basically say, or large language models, that I can predict the next token. Now, that next token can also be, made to follow certain instructions. They can be made to follow certain sequence of tokens. And that is what we leverage in terms of building what we call these tool support. So a model can tell you, I need to use this tool, or I need to use some function, and here are the input parameters to that function, right? And tool calling is probably what's centered to a lot of these projects and that I'll talk about, like Replit, Claude Code, etc., which basically use tool calling extremely well and are able to perform like really complex tasks, right? And so that's what the entire MCP boom was about, and it's still ongoing. And that's the next thing. So what is MCP? MCP is basically a standardized protocol. It's called Model Context Protocol, that basically allows models to talk to a tool in a standardized fashion. So it's just basically says that, hey, I am this tool, I do so and so things, I have these functions, I have these capabilities. That's largely what it is. That allows the model to pick and choose what tool they use. And that has been very helpful, because now the model can say, I want to run a bash command, or I want to basically place an order on your Amazon cart, or I want to grab the latest news from X. So a lot of these tools can do very different things, move certain objects. There is no limit to what a tool can technically do. So MCP is kind of the de facto way of talking to a tool if you are an AI model. And some of these websites, like this is a screenshot from, I think, MCP itself, has like hundreds of MCPs already. So every tool is publishing their own MCP. It's becoming the de facto way for operating. So you just talk to a model and the model does the stuff for you, right? All right. So what are workflows? What are agents? Can we dive into a little bit deeper, right? So workflow is basically a DAG base. DAG is here a directed acyclic graph. So you have a sequence of steps and there are no cycles in it, right? So you basically execute one step, flow to the next, and keep going. There are tools like N8 and Zapier, etc., which help you do this. But effectively, here's an example where, when you receive a chat message, then you process it to a request. Then if something happens, do this, something else happens, do that. So it's kind of very like defined in terms of the sequence of nodes that you want to execute, right? The other option is agents, where the number of steps are not known, and you basically say, hey, go do this for me. And I don't really care how long it takes or what number of steps it takes or what exactly you need to do. So figure it out. So that's kind of the holy grail of AI, where you basically say that I want this, and that it makes it happen, right? So workflow is sort of the precursor to it, where you already have a very sequence of steps defined, and both have their own place. So it's not like when you have an agent, you don't need a workflow at all. Workflow brings a lot of determinism and a lot of control to your particulars. I would say. Workflow. But for an agent, you're giving much more freedom. You're also trusting the A model much more, and you're also letting it take decisions, which in a workflow, largely it's very limited. Cool. So what is an agent? An agent is basically the core component of it is to be able to decide how far am I. So it helps the agent does its own planning. It figures its own set of steps, and it uses the LLM also as a judge. So this is a very important concept that you might hear in the industry constantly, but that's the idea. So you use basically has the task completed? Have I reached my goal? Is something that a reasoning model is able to decide, and you basically just guide it to completed tasks rather than being very specific about every step of the process. So in this case, basically we see that there is a planning loop. There is different kinds of memories around it. In this case, when I say memory, all this is actually being fed into the context. You also have a suite of tools. So the agent is in the center, where it's able to access memory. It's able to access different tools. And then it has an objective that I want to achieve this. Let's say I want to write a test for a certain class. So it's able to go into planning, figure out what all it needs, and then as a next step, it builds out that, hey, I need to read these classes, I need to understand them, and then I need to build a set of test cases, a set of test plan, and then finally probably write the code. So it actually kind of builds this hierarchical list, or I would say a DAG again, and then go ahead and execute it itself. So that's kind of would be an example of what this is. So again, I mentioned about examples. So here are some examples. We have like a good chunk of these tools getting agentified. What, for example, is a terminal where you just say, hey, can you find me these files which have a certain characteristics, or can you move it from here to there, and stuff like that. And the terminal itself would basically be able to figure out your request, break it down into individual commands, and run them, right? OpenAI Codex is an agent that basically, just go ahead and write, entire software patches for you. Same for Claude Code. And there are like all these different kinds of tools which are available in the market now, which has a similar operation. All right. Let's move forward. So this is probably the more meat of the talk, where we're focusing on how you can use AI in product and engineering, right? So let's start with the software development life cycle. Probably most of you are familiar with this, but there are a set of steps that we always do, and AI honestly hasn't changed that much, right? So in this case, we basically follow these steps. AI has probably just sped things up a little bit, but largely these steps still remain the steps. You still need to plan, design, implement, test, etc. Right? So this is the whole skeleton through which we'll probably move as we go, right? So, but for each step, I feel that things have become easier, and I don't want to like go through every line here, but just to give a context. Previously, a lot of these collection of data and analysis was very, hand heavy. So you had to understand, you had to read tickets, emails, etc., to understand what the customer wants and generate issues yourself. But the AI can do it for you. So now you can do this at a massive scale. You can literally read feedback from all your customers, not just the 5 or 10 that posted 1-star or 5-star, but instead you can go through them and you can analyze them, figure out them, filter them, and then build a set of stories. And this is the ongoing trend that you will see across every step, that helps you do these things much faster and possibly even fully automated if your system is up to it. So from meeting transcripts to Jiras, and this has become so much more easier because you can record a customer call, you can transcribe that, and you can probably pick out notes from that, and all of them have now established products around it. And you can take those notes and create action items. And that has sped this from, I don't know, weeks to probably hours, which is massive. And that's the power of AI, where it has changed things a lot, right? So that's step one. So, and then we have design. So now PRDs can be, so easily built. Once you have like a set of user stories, you can create a PRD. Once you have a PRD, you can create, the architecture structure, or maybe how the API contracts need to be. And a lot of these steps maybe tedious or require very sophisticated, like, I would say deep dives over, weeks maybe. That has kind of gone down to like a matter of minutes. So you can flip out an architecture doc, create a sequence diagram in minutes, or maybe, just create a few mockups. Like, otherwise, historically, this would again be like a very long exercise that you imagine some wireframe as a product manager, and then you go ahead and hand it over to your UX team to figure out what the UX should look like, and then the UX UI, and then once the UX folks comes back with a mock, the UI team has to figure out how to implement that mock, and there'll be back and forth that, hey, this is too hard, this probably can be simpler and can be done faster. All of those discussions can be done in like an hour in a meeting window, where you can just flip out 5 different UI choices and then work with the UX and UI engineer in the same room and solve it right then and there. It has really changed the game there, right? Implementation cycle, this is very core to my heart, and that has also been like drastically transformed, or is being transformed with the advent of things like Cursor, Claude Code, Codex. The entire tedious development or maintenance is kind of changing drastically. So you can basically, once you have tickets with properly described items, the AI agent can practically take your ticket and create a pull request. So that's the experience changed, right? So from Jiras to PRs, and yes, it is not perfect at this time. It is still helping us, I would say, do maybe 50-60% of the work, but for simpler tasks, it kind of goes all the way to 100%. I see some question here. Where was that? Oh, maybe I lost it. Yeah, so Moharif says, how does SDLC help us? So SDLC is basically how, I don't know if you had some exposure to the industry, but basically this is the cycle through which you typically go through. And when you're kind of building software in a company, you ideally want to have clear separation of stages so that you can take your idea from let's say sort of an idea phase to a product, right? So you want to break down the problem, understand it, go through different phases and figure out a path for it, right? So that's what the software development lifecycle is about. Cool. All right. So yeah, once you write the implementation, you want to test it, obviously, and these two go hand in hand. And because these agents are able to write code as in the same way, so testing is probably an easy. You can probably relate how that is getting automated as well. So AI is today creating the test plan, and then it's writing it, testing it. What is this? Okay, cool. Yeah, so you can basically create mockups, create a bunch of synthetic data to run your tests, a lot of things. So AI has made this part, and testing has always been a pain point for engineers. How do I test my own code? But now you have this pair programmer with you, and you just say, hey, you know what, find 5 different ways to break this code. And I said, all right, let's write tests. Once you write these tests, so like, okay, how do we fix this? And then you go back to the code and then ask the AI to find out how to fix them. And then you work with AI to fix them. So it has become a much more, I would say, fun session in terms of like basically creating a much more solid product from the very beginning, because AI can give you an independent insight into a lot of the things that you may not even thought about, right? So yeah, testing has been like a huge help with AI. All right, so this part, I would say that it's probably a little more advanced, but deployment and finding optimizations around deployment are the next set of things that are happening, especially for certain complex systems. So normal stuff like creating release notes, document updates, a lot of these things are starting to get automated, which removes a lot of pain point for writers, for engineers who have to update, like, hey, you know what, I created this new feature, this is how you use it, etc. AI is just able to generate all those documentation for you. The release notes get compiled from the Git commits themselves. So that's pretty I would say like hands off versus what we were doing previously in terms of manually writing a lot of these things. CI is another interesting aspect. For if you have like large suite of tests, now AI can actually tell you what are the things that you should first test on, giving you a faster iteration model rather than going back and running let's say a 5-hour test and then coming back to see that, hey, you know what, it failed at a very initial level, so it just wasted my time. So again, we see pretty much every part of the story get affected by AI at this stage. All right, so maintenance is another piece. Basically, once you build all your software, once you have kind of done your product diligence and then you throw it out in the market, the next step is how do you kind of maintain it? How is it doing, right? So you have all of these monitors and in place, and you have all of these metrics that you want to look into. Hey, what is my error rate? What is my latency, etc. What if something goes wrong? How do I fix it? That's where I feel the triaging part of the story is where AI comes in, where it's able to look at some of these issues and categorize or even take action on them based on how you want to build the system. It's able to say that, hey, you know what, this is a P0 that you should look at, and versus this is something that you can probably ignore. And those things are kind of helping you sift through a large number of issues much faster, and kind of give it also kind of is able to prioritize, which otherwise was a kind of manual effort. And some companies like Datadog, Sentry are kind of at the forefront of this, and they are kind of building tools in their product itself. So you can monitor things on Sentry, and you can basically use their Sentry AI to, for example, like look at the important issues first, or even triage them. Hey, why did this occur, right? And I'll share a little bit about that as well. Cool. So Yeah, security. So security is kind of probably the super important thing, right? You don't want your stuff to get broken, because like once your home gets broken into, then it's kind of a bad thing. So you don't, even though security is probably, I mean, you may not have to deal with this all the time, but that one time that you have to deal with, it kind of gets very ugly. So because of the cost of this, security is a super important point for any enterprise product, right? And AI basically is very helpful, because like there are these dedicated security teams in large companies which basically do all of these threat modeling and other things. And now you can actually, being an engineer leading a product, you can literally go ahead and create your own threat models or do your own diligence in terms of figuring out what are the obvious mistakes that I'm making here, and try to avoid them. And that kind of speeds up the entire security review process drastically. And this also makes your, closes the iteration loop way faster. So you can kind of focus on doing your thing rather than iterating with the security team and kind of going through those cycles. From the security team perspective as well, this is very helpful because it helps you create these set of to-do lists much more easily. So it basically, as you can see, like from every part of the cycle, it has accelerated some of these boilerplate stuff drastically. And this is what I'm telling you, it's kind of being used in teams across like large companies. For smaller companies, probably the security team is not that big of an issue, because you kind of do your due diligence within yourself. So AI has really helped there, because now you can kind of just work with the AI and fix your issues. And then you said, okay, I have done most of the 80/20 stuff, and then I'm good to go, right? Cool. So one thing I wanted to touch upon, like briefly, is that for a software development lifecycle, you don't need to do one thing versus the other. So it depends on a very case-to-case basis. I know folks out there are like, oh, agile for the win, or waterfall is bad. The thing is, it depends. And if you have a product that is you're shipping as a physical product to a customer who is using it at the edge, you cannot do an agile model, because there is no product in front of you to iterate on. There's no way to ship. How will you ship? So there are specific models apply to specific use cases, and some models are more important than other. If you're a startup, it's not about agile; it's about iterating quickly. If you are maybe an enterprise with a constant product development and maintenance or something, then agile may work. Otherwise, you may need to go back to planning frequently. So it really depends on what stage you're in, but the core blocks of the software development still are in place, and all of those blocks are getting affected by AI. And what matters is how you use them, and that is up to your particular industry and what do you think is fit, right? Does that make sense? Cool. So just wanted to throw it out there. All right. So so I probably spoke about most of this, but just want to summarize this a little bit. So fundamental principles, stages have not changed. I don't think they're going to change that easily unless AI comes and completely writes everything into it, which I feel there's a little bit of time. Right. The speed of execution at each stage has drastically changed, right? Cost of building alternatives has changed. Today, maybe let's say a couple of years back, when we would build a product, it would be very expensive to try out, let's say, a mock, or let's say create a mock AI and test things out, right? But now you can literally fire up 5 different UIs and see which feels better, right? That is the difference that AI has brought. All right. So as an engineer, what does this mean to you? So as an engineer, now you can focus on solving the hard problems. So a lot of the easy boilerplate stuff has been taken over by AI, and that's what people do. Like when you first solve the pain points, and you focus on your architecture modeling, and you focus on the outcomes, while the rest, of the refactoring, the testing, a lot of the stuff can be just heavy lifted by AI at that point, and you can just review them. Right. And yes, AI is your pair programmer. You basically help steer AI with, rather than doing all the hard work yourself. So that's basically the idea here. Okay. So I see a question, Dr. Anamitra Roy. With the advancement of AI, will we humans not at all required to think about innovations? Will AI fully take care of it? I think we are far away from it at this stage. I still feel that there is a long way to go for these models. The idea here is to innovate and help AI improve scientific outcomes. So AI is helping software, AI is helping science. So for example, if you look at a model like AlphaFold, which can basically predict the structure of a protein, that has unlocked, so just to give you a scale of things, right? We probably manually would predict how a protein 3D structure would be, and we would do this like a few thousand every year or something. I forget those statistics right now. And we probably had the structure of around, I think, 10,000 or so proteins at that point. When AlphaFold was released, and today, it kind of went to, like, first of all, just by using software, it was able to give a 90% accuracy, where scientists took it would spend a majority of a year to predict the structure of one protein, and it would take months to do so with like a 50-70% accuracy, right? And AlphaFold comes in and says, oh, I'm just going to use a neural network, and then I'm doing this at 90% accuracy. And so suddenly, from a few thousands of proteins, which we knew what the structure was, now we have the structure of around 200 million proteins. So everything that existed so far, whatever we know, has run through the model, and we know the structure of it. So, like, given that scale of innovation for something like this, we are able to now do things which was previously not possible. So now you can because you know every protein structure, you can figure out the interaction of drugs with it and what to do with it, right? And that's not my area of expertise, so I will probably leave it there. But the idea here is that these tools will continue to improve and aid, and we probably will steer them for a long time before we start using them again for exploring different ideas and probably implementing end to end. So, and there is a huge technical stack that comes to fill in that gap as we go. Models need to get better. Long running tasks need to be more stable. So yes, maybe eventually, who knows what's the timeline given the exponential nature of things, but not there yet. Far from it. This is just probably, I would say, the early stages of it. Cool. All right. So yeah, AI accountability. Yes, humans need to validate. AI does dumb things, really, really dumb things. I don't know if you guys have played around with it, but sometimes it will do the exact opposite of what you wanted. So it's very important that we have, we review them. And often you can use AI to review AI. You just keep those threads separate. And those are some tricks that you can probably use to make sure that you don't review the dumb stuff. But at the same time, you actually need to go ahead and validate and figure out that, okay, maybe this prompt worked, maybe that didn't. Here is how I would keep the AI aligned on my side versus just, going on continuously prompting to a point where it's unable to have clear clarity in thought process, and it starts emitting random stuff. Right. Cool. So let's touch on security a little bit and observability. So again, fundamental principles still apply, right? In this case, if your intern shouldn't have the right, neither should your agent. So these things are probably obvious. So you don't want to give an agent unnecessary access to a lot of things. That is like classic security principles. You want to make sure that your general principles of security hold. So you want to make sure that your data, and also basically there's a CIA triad, right? Confidentiality, integrity, and availability. So you want to make sure all those things are in place. So your data is your data integrity is protected, your availability is restricted, and we have basically a principle of least privilege, meaning that folks who do not need to have access to your data should not have access to it. Like, same applies to an agent, right? You cannot give an agent, edit, delete access to things which it doesn't need to. So if it is just an analytics agent, so it probably should just have, access to get commands, right? So it's basically clear separation of basically things like these that help you secure things from unnecessary problems, right? And you also have like clarity and separation of duties. So an agent which is reading data on a service X has nothing to do with service Y should not have access to service Y. And those are kind of the basic principles that security teams follow, and so should the AI. And there's no difference around that, like how we think about it. So we can possibly think of an AI agent like an intern and start building principles on top of it. So, for example, if a new engineer comes on board, you don't suddenly give them push access to master, right? So they usually will create a pull request, and a mentor or somebody senior would review their pull request to make sure that they understand what they are doing. So, right, and you iterate with the junior engineer or the intern to make sure that the PR is as per the product guidelines. It is doing a certain feature. It is achieving the required goal. Exact same thing applies here. So in this case, you give the AI agent ability to create a pull request, but there needs to be proper process and automation to make sure that that pull request is sane, and you can merge that. So that's how I would think about security. This applies pretty much across the board in terms of principle, like having guardrails and, like, for example, isolated environments for the AI to play with. All these things help you keep yourself safe and also damage control very quickly, right? And AI tools can do a lot of things, but it can also break things. So having those guardrails early and investing in these guardrails and protections early go a long way in keeping any issues at bay. And so you can only get the plus sides of it rather than having to see the downsides. I see these Twitter posts which basically say, hey, AI deleted my production database. I'm like, okay, why did your AI have access to your production database with delete permissions, right? So that's the kind of questions that we should ask. Like, yes, it might do something dumb, but having that access to do it in the first place is something that needs to be questioned, right? All right. So I have another question from, I think, Maruf. What is the primary security concern highlighted regarding an AI agent's interaction with production environments? So primary security concern, like if your agent has access to a production instance, it might as well have the need to access that production instance, right? So for example, if you have an agent that is monitoring production environments and it is accessing a production environment, that's legit, right? So you want your monitoring agent to have access to production environment. But let's say if it's somebody's dev agent trying to do something and it magically just finds access to your production instance through some keys, it was available locally, and that kind of is a bad model. So you want to control how folks are getting access to production, and you want to control basically have basic software engineering principles, like in this case security principles in place, so that you can guard of this. So what is the concern here? A concern here is that if the AI does something dumb, who is responsible, right? And what is the impact to the company at that point? So for example, if your AI goes ahead and compromises the database, let's say corrupts some data, even removes that data, for example, it can be very expensive to a company. And it could be, even most organizations have backups, but getting to those backups and restoring them is not like, a flip of a button and everything comes back. Deleting is much easier. What if it deletes pods on Kubernetes? So any critical operation like those, we need to be very careful about. So giving an agent access to it means giving putting yourself in the path of those things to happen. So you want to make sure that, yes, this is what I want to do. Do we delete pods in production? Yes, sometimes pods get evicted. Sometimes we need to refresh things. Things get stuck. You need to do it. But letting an AI agent do it at that time is great. Is it being monitored? Have we tested it? Is it not taking any so for example, if we are making an agent who is doing these operations in production, How confident are we that it's not going to do the wrong thing? These are the questions that we need to get answered, right? So those are like super primary security concerns that concern an agent if you're like talking about production environments. I hope that answers that question. Cool. All right, let's touch upon on observability. So I think the central theme here, I was sharing a little bit on in the maintenance section, is that when you deploy a product, you want things to be visible. And this is again coming from, this is standard, observability 101 that we follow in the software industry, right? So let's have metrics, let's have visibility on those metrics. So, things like latency, error. If I deployed an API service, I want to make sure that the number of errors are close to zero or whatever, a minimal number, right? I don't want like the errors to just skyrocket. That means something is going wrong. So those are the basic things that we want to keep a look on, and AI just helps you keep a look on that much faster in an automated fashion, right? There could be some interesting metrics once you turn go into the development stage. So for example, if you're using AI to create pull requests, your metric could be that percentage of pull requests that were drafted as an agent. So how effective is AI in your organization, for example, or what is your test coverage? What are the number of flaky tests that AI is writing? This may not apply to a lot of enterprise companies as of now, maybe. But if you look at startups, a lot of the code, like 60-70% of the code is being written by AI. And this is stuff that, these are like thousands of lines of code. Who's going to validate it? Well, you want to have tests in them. But these tests, again, need to be stable. So, right, those are the kind of things that you want to make sure that you have eyes on that, hey, when if a build is good, the test should pass. Simple, right? And that is the other kinds of metrics that we want to look at. So there's this production metrics, and then there is these other kinds of metrics that give you observability. So basically having eyes on your system, right? What is happening? Service level objectives, sure. P95 latencies, that is another, I spoke about latency, and cost per request. So for example, if you have for some reason, if your application is going into a loop with an agent and it is kind of going through crazy thinking cycles, which is costing a lot, for example, that could be a concern. So observability is about exposing the right set of metrics so that you can have a clear insight to what is going on. And with AI, things change a little bit, right? Because AIs are non-deterministic. So that's part of this thing. So because they're non-deterministic, the way you monitor them or observe them is different. So one error possibly in a code base would mean an error every time. But the error made by a model may not be always the same error. It may change. So instead of measuring one outcome, you would probably measure 100. And if more than, let's say, 20% of them are failing, then you have a problem. If you're, let's say, 80% time you're working correctly, probably that's fine, right? Depends on your use case again. But yeah, so you use things like golden test pass rate, etc. So all these are probably things that you would look at. All right. So I'll probably skip through a few things here. So I'll jump directly into this part where good observability powers faster resolution. So the core idea here is that when you have all these metrics coming in, it is very important to figure out what is the outcome, right? And root cause analysis was something that is very manual or has been very manual for a time, right? And with the advent of AI now, when you have metrics, when you have input data, when you have environment data, now you can actually correlate them on temporal basis and figure out what went wrong. So let's say if let's say my advertisement revenue dropped in a certain country, why did it drop, right? Can I take all the data around it? Was there a holiday around it? Did our systems fail there? Was there some outage there? What could be the reason? So if you capture all of these events, if you capture all of this data, now AI can actually correlate and tell you what root cause analysis is. And then it can possibly take the next step and try to validate if this hypothesis is true. And it can also possibly provide other candidates. So with AI, now that you have all the related data, root cause analysis, which was actually a very hard problem, starts to become a lot more digestible with reasoning models coming in, right? So that is probably a sector which is improving a lot, and automated analysis and triaging is something that is becoming very, very important in terms of the observability sector. Cool. So I think that mostly wraps it up. All right. Let's do a small demo on a Claude agent. So I don't know if you folks have used Claude, but Claude is actually an agent under the hood. And in this case, let me show you a small example where I'm trying to find what are the latest research trends happening in AI, right? So this is actually a video. I'll pause here and there and I'll try to share comments on to what this is. So in this case, I start with, let's say, collect all the archive trends and then plot me a nice live dashboard, right? And I ask it to go research. So what the agent is now doing is it's going through different sets of articles. And this is a fast forwarded video, by the way. It is actually in multiple minutes that this happens, but it's able to read through different kinds of articles, and it tries to get together and then build me this final report, right? And once it does build this report, I actually go ahead and say that, hey, can you take all this research here and build me visualization for this, right? And so it has done all this analysis on archive and similar websites. Now can you give me a dashboard? So then what happens is that, like, now that it has all this data in context, it is able to take all of that data and then create a live view and help me visualize it, right? So it writes all of this HTML code, and without me having to touch a button, it is creating and building me a dashboard. Now notice that there is an error in the bottom that is there, but overall, it is able to come up with monthly submissions in different papers and active trends, etc., with very little effort on my end, right? And there is an error actually in the bottom, and I just say, hey, what, can you help me go fix it? So I just say, hey, can you fix the error? And I don't even tell it what the error is. It just goes ahead and says that, oh, I figured out what the problem is, and then it goes through multiple iterations, and finally it does fix the error, as you will see. Cool. So this is what an agent can do. So this is a whole sequence of actions, right? So figuring out what the issue is, figuring out how the research actually started, and then now it's able to give me a category-wise breakdown. So, yes, RL fine-tuning is a top research topic. Reasoning models have been, very active. So these are like, valid, directions, for AI research that is ongoing in the current community. And it is very helpful kind of knowing where the industry is going, and this, you can build this little tool for yourself in a matter of minutes that helps you do this, right? And it gives you a heat map, research growth by topic area. It's actually pretty extremely powerful. And now if I wanted something more specific, hey, can you focus on RL or reinforcement learning and tell me a little bit more about it? What are the trends here? What are the new things coming up? Can you read those papers and come back? And it can actually do that as well and come back to you with more research. So identifying directions has become a lot more easier, right? Now, what can you do with this? So this is just one example. You can cook up several examples on building UI, building maybe a code base, etc. And this is live, so your numbers are actually changing on on the fly. And this is pretty amazing, right? So how long would any one of you take to build something like this, right? For me, I would personally take quite a bit to build something like this, which is so detailed and feature rich, right? This can be done in minutes. All right, so this was the demo. Now, let me, so this is actually published. So if you want, you can actually go to this URL and try it out yourself. This is an artifact, and you should be able to use this. So you can actually now with Claude, just go ahead and create these artifacts and share it with people. I don't know whether you folks have tried it, but it's out there. Cool. So I'll just wrap up with a few things, practical tips. It's important to close the loop for an agent. When you're working with agent, you need to let it figure out yourself. So if it runs into an issue, you want it to figure out yourself. But otherwise, let agents build, test, and run your product, right? So you don't want to be testing the product for them, because it doesn't work if human is in the loop, because at that point, you are the bottleneck. Let agents receive the feedback and stay out of the loop as much as possible, like I was saying. So this is tip number one. I'll speed things up in the interest of time. I think I've kind of overshot by quite a bit. So minimize context used. Like, even though you have a huge context window, it is very important to keep your context minimum. Focus on one little thing. When you're working, you're probably most efficient when you're just focused on one thing and you get it done, right? And that's the same for agents as well. When you're in a model, try to make sure that you're not talking about 5 different things in one context. Focus on one thing, get it done, clear everything out, move on to the next. That's how I would look at it, right? Having the best tools. If you have the right set of APIs, if you have the right set of tools that you actually need, things will happen faster. LLMs don't want to get confused with 5,000 functions being thrown at it, and then you pick and choose which one works best for me, right? It doesn't work that way. So if you keep it a set of 10 functions to use or 5 functions to use, each with a dedicated use case, and this is how you use it, this is what the schema is, etc., it works so much better, right? And that is what I feel I have learned the hard way. So I would say, and yeah, remove tools that you don't need. If you want to use them later, add them back, no problem. Keep things in context and always treat context with importance. So that is the key thing out of it. Lastly, I think working with AI requires a mindset change. It's different from being a doer to being sort of a manager or overseer, right? Implementing the best practice and guardrails. Often when we do things, I'm like, yeah, forget about this. Let me just focus on the meat. But with AI, it's different. You have to put the guardrails. Otherwise, your AI is going to think the exact same thing and start doing things that you won't like, right? And yeah, the speed of the industry is insane. The growth rate is crazy, right? So keep learning, iterate early and often. Before you solve a problem, a new technology might come in. So it's important to stay aware, stay up to date, and keep learning, right? And yeah, stay positive, embrace the possibilities, and be part of this change. So I think it's a very exciting time. The entire industry is changing as a whole. And excited to be part of this. I'll now wrap this up. Sorry, Rahul, I think I probably overstayed a little bit, but I think that wraps up my session.
Great. Thank you so much, Suvodeep. Really, really appreciate it, and quite eye-opening for a lot of audience. I have just one last question, since we have 2 minutes. So suppose somebody is doing their computer science engineering right now in a college in India. So what should they learn? How should they learn something that is a bit long lasting? And just a follow-on question to this, a lot of students who are in this chat, they are in AI and data science field. So not necessarily they are coders, but they are in the AI and data science field. So probably they'll be working with data in their careers. So a little bit of a few tips for them, how they can think about their careers in AI.
Yeah, great question. So I'll try to tackle them one by one. So in terms of if you're a computer science engineer, first of all, then use AI by your side, right? You can, if you're applying to companies, then you know which company. You ask them, okay, what are the kind of things that they ask? What are the things I need to learn, right? And you can use AI both as a learning guide versus just as a competitor. Look at it as a competitor. So one of the things would be to the fundamental principles still hold. Companies still want to check, hey, is your basic strong? Do you know how to code? Because if maybe the AI can code, but you are the judge of that AI. So you need to also understand what that AI is doing. If the AI is coding something dumb, then, and if you're not able to figure that out, then that's a problem, right? So you want to make sure that you have the basics in place. So a lot of companies are still using the traditional lead code. They're still using system design. They're still using a lot of those standard ways to probe an potential candidate to figure out if they know the basics. And then once you all have mastered the basics, when you're using projects, so today it's not just your interviews, right? Your projects out there, publish a lot on GitHub, create interesting things with AI, where you have you spend an hour, couple of hours on a weekend and create something fun and share it with recruiters, share it with the teams that you're looking to interview with, and they'll see you're curious. Here you can actually use the power of AI to create all these things with much more little effort than it was earlier possible, right? So you basically use AI by your side. Ask AI in terms of, hey, if I was, am I thinking right in terms of this algorithm for lead code? Like, can I optimize on it? What are possible ways around it? It's extremely helpful in terms of even doing traditional ways. So it has, I think, a lot of benefits for a learner. So I constantly learn from it. So that's one thing. The second question is, how do data science and ML folks can help with it? Well, first thing is obviously like prototyping, right? So if you want to use AI to prototype things, now AI can actually build the neural network for you. So you can literally use AI to build AI, right? And that is like phenomenal in terms of not just for learning, but also for doing a project. So if you have a data set, like can I just ask the AI, hey, can you look into this data set and give me some interesting statistics around it? I'm looking, hey, what's the just default data structure, like statistical things like mean, median, mode, and other stuff that gives me an idea of what the data set looks like. What does the distribution look like, right? Can you plot that out for me? Okay, what kind of algorithms should I use to sort of approximate this? So if you kind of go back and take a top level view and then ask AI to help in each of these phases is something that would be very interesting. So I feel that it doesn't really matter which discipline. I think given the amount of knowledge that AI has within itself, almost the entire internet within it, you can use it as a learning tool. And then once you have the fundamentals and basics in you, you can go ahead and implement with it. So that's probably the strategy that I would recommend.
Great. Thank you so much, Suvodeep. Really appreciate your time. It's early morning in the US, so thank you so much for making time at this hour. Final words for the audience. Thank you very much for making this a huge success. I could see at one point more than 1,000 concurrent live stream viewers. So great. Thank you very much. And many of you have also asked in the about the certificate. So you'll get an email post the webinar. You have to fill a feedback form, and you have to make sure that your email is verified, and you will automatically get the certificate in your inboxes. So great. With this, I think I'll end the session. Suvodeep, any last words? And then I think it's about time we'll end the session after that.
Oh, thanks a lot. Thank you for having me. This was fun, and I hope the audience maybe learned something out of it. And yeah, grateful to all who have been attending this. Thank you so much.
Thank you, everybody. Bye-bye.